Hello, good morning, everybody, or good afternoon. This is your first assignment in Mr. Nullum's class, where you have to annotate the engineering process of a given text. And so the A direction says, read and annotate the following passage using the 11-step process. Find the lines where these steps apply. Each line can share the same line. So if we look here, we have the 11-step process of engineering. Step 1, understand. Step 2, explore. Step 3, define. Step 4, idea. Step 5, prototype. Step 6, choose. Step 7, refine. Step 8, present. Step 9, implement. Step 10, test. Step 11, iterate. So pretty much what I'm asking you all to do, I'm asking you to read this text below, and each line has a number, and I want you to try to figure out where are these steps in that passage. And you can see here steps 1 through 4 are done for you already. And so I'm just going to highlight just pretty much how I found this information. So let's go ahead and start. So when we start off with step 1, which is understand, define the problem, it says, in a competitive robotics, there are typically numerous problems that need to be solved by the design team. What is the most effective strategy for playing the game? How do we win matches? These problems and questions all have many answers. Some answers are better than others. How does the designer go from finding the correct solution or the correct answer? And so we stop here, and you can see that that is pretty much the part where you're questioning. You're trying to understand what are you trying to do with your design or challenge. And so that's why that part 1 through 6 is understand. Line 1 through 6. All right, so now let's go to step 2, explore and do background research. So go where we stopped off of. It says, in this step, engineering will do background research on the problem they're solving. They will investigate the following ways others have tackled similar problems. Engineers will also gather detail on the environment they're dealing with, the situation the solution will be used in, and the ways it will be used. And I think we can pretty much see that when that stops in competition, in competitive robotics, you're talking about something new. So we know that 10 is where we stop and 6 is where we begin. So for doing background research, those lines were 6 and 10, 6 to 10. All right. So the whole purpose of this is also to get you to read more. And so I don't want you to be intimidated by the amount of reading I'm asking you to do. I just want you to accept the challenge and just do it, and even if you have some issues or problems, I still want you to just do it. Okay. So the next part says, in competitive robotics, designers are presented with some challenges or games in which their robot will compete. This challenge often includes a manual containing a series of restrictions and requirements that every robot must fulfill. These are design constraints. Another self-imposed design constraint revolves around the team's capabilities. One of the most important parts of successful generating design constraint in competition robotics is to understand one's limitations. Many teams are tempted to overstress their capabilities by exciting designs. Every team needs to understand exactly what they're capable of so they don't end up missing a target. Capabilities often depend on manpower, resources, budget, experience, and more. Teams need to generate concept strategies, concepts for the overall systems, and concepts for individual subsystem mechanisms. Some of these systems will be dependent on the influence of each other. And you can see from the last line, 25, all the way to where we started, we're in competitive robots. That is the third step, which is define. Define what your team can do. Define your purpose. Define pretty much like, what you're able to do and what you're not able to do. And once you realize your strengths and your weaknesses, you can better plan and make a better, more efficient, effective robot, because your robot is going to be playing off of strengths, not what you want it to be. You have time, you have budgets, you have to be able to work in a timely manner, and you have to be honest with yourself. So that's why define is line 10 to 25. So we're going to go ahead and do the last part, which is idea, generate concept solutions. So line 25, it says, brainstorming is an exercise in which groups of individuals work together to generate large numbers of ideas. Some important rules for brainstorming. Team focus on the quantity of ideas generated, not the quality. Reserve judgment and record everything. Designers should test. Wait, no, I think that's it. Yep, that was it. Brainstorming is an exercise. I'm going to highlight this here. Brainstorming is an exercise in which groups of individuals work together to generate large numbers of ideas. Some important rules for brainstorming. Team, focus on the quantity of ideas generated, not the quality. Reserve judgment and record everything. And that's right. That's what brainstorming, that's how you get ideas. You just have to just write everything down. And it doesn't really matter if it's a crazy idea. You should allow all crazy ideas to flourish. And so that's why that's line 25 through 29. All right, scholars. So the next thing I want you to do, I want you to finish steps of 5 through 11. So you have to read the rest of this passage and try to figure out where these steps lie in this text and passage, and list the lines in this blank right here. I'm going to give you a sheet so you can just write on that. But again, don't be intimidated by the amount of reading. I still want you to just do it, complete it, and look over it at least 5 times to make sure that everything you got is correct. All right, thank you.